We have given square park side 2C. Use coordinates to determine wherever a snag card at point G is the same distance from each corner. So we have to show that the distance, if we put that this is our A, B, C and D, we have to show that the distance from AG is equal to CG. Let me write this. AG is equal CG and is equal BG and is equal DG. So first let's put this square to the xy plane. If we extend AD, this will be our y axis and AB will be our x-axis. Because it's easy to find the length of horizontal and vertical segment and distances from 0, 0, so that's why I place one vertex at the origin. So this point has coordinates 0, 0, and the two sides I put side AB on the x-axis and AD on the y-axis because it's very easy to find length of horizontal and vertical segments. So if here we have A, so because this square park is the square and side is 2S, this mark means that these two parts are congruent. So here will be C and point B will have coordinates 2S, of course, is here, 2S 0 because on the x-axis the second coordinate is 0, and now the same will be on the y-axis because this is square and we see this red mark, so it means that these sides are congruent. So we have here S and point D will have coordinates first 0 because on the y-axis first coordinate is 0 and the second will be 2S. Next we can find coordinates of C point because this is square, so it means that these parallel sides are congruent and this point will have coordinates the same like first like B, so this is 2S, and the second like point D, 2S. And we see that point G is on the middle of our square. So first coordinate is S and second is S. Now we have to show that AG is equal to CG to BG DG. So we will have to find the distance between points AG first. So AG is equal, let me remind you formula. If I put that this is our x1, y1, x2, y2, the formula for the distance between point A and G will be square root of x2 minus x1 to second power plus y2 minus y1 to second power. So AG is equal square root, the G is the last, so we have S minus 0 to second power plus Y is S, so we have S minus 0 to second power, so this is equal square root of 2s square. So this is equal s square of 2. S is positive because s is side of square. So now we have to find CG. We have to use the same formula. Now the last point is G. So we have CG. So we have s minus 2s to second power plus s minus 2s again to second power. So this is equal square root of s square plus s square is 2s square. So this is equal s square root of 2. So we got that AG is equal to CG. What next? We have to find BG. G is the last and B has coordinates 2s 0. So we have square root of s minus 2s to second power plus s minus 0 to second power. So this is equal square root of 2s square. So this is equal s square root of 2. So we see that BG is congruent to CG and AG. And the last we have DG is equal square root, again now G again is the last, D is first. So we have s minus 0 first to second power plus s minus 2s to second power. So this is equal square root of s minus 0 is s to second power plus s minus 2s is negative s to second power will be s square. So this is equal square root of 2s square. So this is equal s square of 2s is positive because is the side of square. So we see that we got that these 4 sides are equal. It means that the distance from G to each corner is the same. We have that AG segment is congruent to CG and is congruent to BG and to DG. This is my solution.